So now we can do that. So what we are looking at is so we've got y x cubed cos x. So cos x, huh? So again, once you see this, you know that you're dealing with a what? Now that you're dealing with a product rule, isn't it? So you say, okay, so my u is what? X cubed. Then your v is cos x. Then you're going to say now your u prime, or the derivative, is going to be 3x squared. Then the v prime is what? Is minus sin x. Okay, so just give me a moment. Okay, anyway, yeah, so you have that, right? Then remember the formula is u times v prime, then v and u prime. So then we're just going to plug in those things into our equation. So we have the u, then we have then v's, then u prime, isn't it? So now okay, so now what you then do is you now try to just basically rewrite these things, isn't it? So you would say so if you want to simplify this, you can then be able to you can then factor out the what? Factor out the x squared, okay? So so you can factor out. Yeah. So that's how you'd answer that, right? So remember here we've used the what? We've used the product rule, huh? So let's now look at another question. So now what then we're going to do now, we want to find for sin x over x. So what you do is this is your u, this is your v. So you say u is sin x, then v is your what? Is x, and then so you want to differentiate. This is cos x, then this is 1. So we know the formula we use. So it's v u prime plus u v prime, isn't it? So primes, we know it's just after you've differentiated something, isn't it? Of course, it's going to be over v squared, right? So what do you then do? So you just have to start plugging in the values, right? So you're going to say your v is x, your u prime is cos x, then your u is sin x, and then your v prime is 1. Then your v is what? Your v is x. So making v squared, you put that squared, right? So then what you do then is, so after this, oh sorry, I made a mistake. On the bottom it should be x squared, okay? So it should be x squared, not just x, huh? So it's x squared, so it's 2x, and then here it's 2x, not, yeah, so just pardon me there. It's supposed to be x squared, huh? X squared. So I have to change those, huh? So I have to change those. So for v, it's what? X squared. Then for the derivative of v, it's 2x, huh? Then it means that even the denominator changes, because it's now x squared and then square it, huh? Okay, great. Yeah, now with that correction made, we can proceed. Then now what we are going to do now, we are just going to rewrite this, so just to make it look a little bit neater, so we write x squared cos x plus 2x sin x over x power 4. Now here, as you know, you can simplify these things, huh? How do you simplify it? You can factor out x from the numerator. So
Sir,
yes,
when using the quotient, aren't you supposed to put a negative sign there rather than a positive sign?
oh okay, oh yeah, sorry, oh yeah, supposed to be a negative sign, right? Or a subtraction sign, yeah. Thank you very much. I think the product rule, I think that's why I made that mistake. But anyways, yeah. So you always what? So thank you very much for that correction. Oh yeah, so that's about it, right? So you're subtracting. Then for the product rule, it's where you're adding, right? And it makes sense because we usually say um you know division and like how you could remember this is division and subtraction, they are not commutative, right? But multiplication and addition are commutative, so that's why the product rule goes with addition, okay? So that's how you could remember that. So otherwise, thank you very much for that correction. So then, yeah, so here now you can factor out, right? You can use a factoring here. So if you factor out x from this, you're going to have that. Sorry, let me write it properly. So you're going to have that. So you're going to have that. And then you're going to have 2 sin x. Then here it's x. Like that, huh? So you cancel the x. So you cancel the x, you're going to have. Yeah, so thank you very much for that one. That gave us the correction. So that's how you would answer such questions, right? So remember, the key thing is to just be able to identify which rule is appropriate for what time or for what kind of question, right? Once you do that, it becomes a little bit easy. So let's look at another question. So that's x minus tan x, huh? So that becomes our u, that becomes our v. So our u is 1 plus sin x, then our v is x minus tan x. Sorry, that should be tan x, right? So we're going to have tan x. Okay, let me just write it properly. Okay, there, right? So now what do we have? So u prime, so u prime is going to be what? So that 1 becomes 0, then that becomes cos. Then for v prime, that x becomes 1, that tan becomes sec squared x. So it's 1 sec squared that. So meaning once you have all that, so you see that like, so why I like doing them separately is that it helps to avoid errors, because once I've put them like this, I've written them like this, then I put up my formula, it becomes a thing where I just have to be what? Just have to be yeah, just plugging in the values, and that way it tends to be what? It tends to be much easier, and of course you are less likely to what? To make errors. So what you do is you do v u prime minus u v prime. So remember, prime is what we have differentiated, then over v squared. So then what we are going to have is where is our v? So we're going to have our v, which is going to be, so our v is what? Okay, so what we do now, where is our v? Our v is x minus tan x, and then what's our u prime? Cos x minus u times v prime, or over what? V squared. So once you look at that, honestly speaking, I hope everyone can agree with me that it's better off leaving it here, right? Yeah, yeah, because even if we try to play around this and want to cancel something, we can't really do much from here, right? Yeah, so yes.
Like, like there is cos and then there is tan there. And we're supposed to have sine. I don't know. Like if we say cos times x, it's giving us x cos x. And then cos times tan x, can't we say sin x?
Which part, first of all?
The first part, x minus tan x times cos x.
Yes.
But
Oh, so you're saying that you can say since tan is sine x over cos x, so we cancel that. Yeah, so we cancel that, and then, but again, that means that you also have to uh multiply that cos x with the x there, right? So eventually you're going to have x cos x minus minus sine x, right? Which, yeah, looks simplified, but would not really change much. But yeah, you could do that. You could do that. Yeah, you'd always want to simplify it. But for me, I feel this would still be okay. But if you want to go down that extra route or route, that's still okay. That's still okay. Yeah. So that would still be fine, huh? Okay. So now, so that's something that's important to take note of. Okay. So now let's see if we can look at other other examples. So there are going to be other questions where you have to differentiate something like this. So what you're going so you're going to have a situation where what you have to differentiate is a function which is in a function. So a function of a function, right? So how you're going to do this is you find the derivative of the f function. Okay, so the derivative of the f function. Okay, so so okay, so basically what you are doing for these questions is you see that there it's saying what? It's f prime, right? So it's f prime, but then you keep the inside. Okay, so you've seen that we've maintained the inside like that, and then what you do, then you then multiply this by the derivative of what? By the derivative of what's inside. Now don't worry, this may look all over the place, but you when we do a question, it's going to make sense. But the point is you differentiate the f, the f of x, or rather the f, the function, leaving what's inside the same. Then we then multiply by the what? By the derivative of what's inside, right? So so now, of course, you may have seen that throughout what we've been doing, we've usually been using either u or v. So let's use u. So if we say u is g of, okay, is g of x, so meaning that our formula would be what? Would be f prime, then u times what? Times the u prime, isn't it? So that's what we'll do. So now, since we are focusing on trigonometric things, let's do the let's look at this. So for this, how you're going to do this, you're going to say, first of all, you are differentiating what's outside, isn't it? That's the sign, right? So you say cosine u, and then you multiply it by the what? Then you're going to multiply it by, so you're going to multiply it by the what? Then multiply by the u prime. So since, let's look at something that we're already familiar with. We know that if y is equals to sine x, we know that the derivative is what? We know that the derivative, we know that the derivative is what? Is cos x. So let's see if what we've talked about can work for this. So remember, our u is what? We can take it to be our x, isn't it? So what we are going to do is, what we are going to do is, uh, of course, we get, so we're just trying to show how this principle works for us to get cos x from sin x, isn't it? So what we are having is, if we've got something like sin x, and then now let's use our method. So first of all, we differentiate. So our u is like this x, isn't it? So our u is this x, right? So what do? We know we've got u prime. U prime is going to be 1. So differentiating what's outside, sine becomes cos, isn't it? Becomes cos, right? And remember, what's outside, or rather what's inside, remains the same, right? So that's cos x. Then, or if you want, you can use u right now. So if you want, you can use u, then we'll substitute later on. So cos u remains the same, multiplied by u prime. U prime is 1. So substituting x for u, we are going to say what? Cos x. So hope you see that this particular concept pretty much works for this, right? Of course. So now, for everything else that we discussed yesterday, by everything else I mean those tan, sec squared, all those things that we discussed, this method works for them as well. Now this is very important because there are going to be certain times where you may want to differentiate something that has got something within it, right? So let's look at these things. So just look at quite a number, since these are things that we already looked at, and so I just want us to be able to appreciate just that difference, huh? Or rather, what we've talked about today. So dy dx is what? Dy dx is going to be, so what's on the outside is gone, one is sec squared u, then multiply what? Multiply by u prime, isn't it? So that's how you are going to do it. Now of course, um we may now want to look at the questions, right, that you would meet with this. So let's say, so we say, now sine 5x. So how do you do that? So here the key thing is, you want to remember the formula, right? So remember, for something like this, we are saying sine u. So we know u is 5x in this case, isn't it? Is 5x. So differentiating the sine, we are going to get the what? So differentiating the sine, we are going to get we're going to get cos what? We're going to get cos what? We're going to get 5, or rather cos u. Okay, because remember the u doesn't change in the first step, right? Or rather on the first part. So it's cos u, but we know what cos u is. Then u prime. What's u prime? U prime, that's what derivative 5x is just simply what? Is 5. So you write that. So basically what you're having is dy dx is 5 cos u. So now let's now substitute for that. So you have 5 of x, right? Of course you want to put brackets there just to make it fine. So you see, so that's these are the kinds of questions where you want to apply these kinds of what? Why you want to apply these kinds of principles. So let's see if we can look at another one. So we're going to have why?
So I had disconnected. Did you delete them?
Yeah, I've deleted. Okay. So yeah, so just be telling me when you're about to take so that so that I don't delete. So okay. So now with what we've now talked about, so let's now see how we are going to solve this, right? So let's see how we are going to solve this question. So now we always go like y. So we make our u to be what? To be 3x. Sorry, to be x cubed. So u is x cubed. So we are going to say cos u. Then differentiation. So remember the formula is what? We differentiate that, then times what? Times u prime. So meaning we have to find our u prime or derivative of u. So that's going to be what? 3x squared. So what you do, you say cos, oh sorry, let's differentiate cos. So differentiating cos is what? Is minus sine u, isn't it? So the u is maintained. Then what's our prime? U prime. Our u prime is 3x squared, right? So at this point we'd want to replace our u now. So replacing our u, you then say u, remember there we've written that, right? So hope everyone has understood this, right? So I'm sure you've seen quite a couple of these in your tutorial videos. So let's see. Can we look at can, let's see what we can look at. There are quite a number of interesting questions that I'm contemplating if we should do, but I think let's do, since there is no beauty in rushing. But we haven't dealt with everything. It's better we take time, but we've taken time doing the right things. Okay. So what then we are going to do at this point is, okay, let's look at this question. So that's that, right? So how do we differentiate? We always make our what? Our u. Our u is x squared. Then our v is what? Oh, sorry, pardon me. Our u prime is 2x. So that's what we are having, right? So how are we going to do this? So we're going to say the derivative. We are going to have, so it's just our way counter. So I work out we are having sec u times what? Times u prime. So what is sec u? So remember we said sec u is what? Derivative of sec u. Sec u is what? It's going to be sec u plus tan u. Then remember we are multiplying by what? By the derivative of u, which is 2x. That makes sense, right? Or if you want to make it more uniform, just put u prime. Then at this point now you just have to replace. You replace u prime, you replace u, then you've gotten your answer, right? So what you do now is say sec x squared tan x squared, then everything multiply by 2x. Then just to write it better, it's best you put the 2x in front so that you then have, so ensure, but there shouldn't be too much, okay, between the 2x and the sec there shouldn't be too much space. They shouldn't look like they are separate things, huh? It's the same thing. And yeah, so you see that, then plus, oh sorry, there's not supposed to be any plus sign, pardon me. There's not supposed to be any addition sign. There's not supposed to be any sign like that. So yeah, it's supposed to be like that, right? So yeah, so having done that, um yeah, so then yeah, then we are going to have tan what? Tan x squared. So that's how you want to go about these questions. So that's about it, right? So once you substitute u, it then becomes very easy because you'll be working with a relatively easy concept, huh? So that's about, so let's see how we can look at another questions. So tan sine 4x. Okay, so then how are we going to do this? So remember, don't let, when the question is big, let make you doubt the concepts, huh? So the concepts are always what? So the concepts are always going to be the same, huh? So what you're going to do is, so let's look at, so what's our u? Our u is sine 4x. So now let's let's find the derivative of this. How do you find the derivative of this? Again, the same concept, right? You say, you write this as what? So you first differentiate this, it becomes what? It becomes cos 4x. Then you multiply by the derivative of what's in the brackets, isn't it? Just going to be 4. So meaning your answer is what? Is 4 cos 4x. Isn't it? So something like that, right? So we've got our u prime. So meaning here it's just a straightforward thing since we already have everything. So what's the derivative of tan? Tan is what? Sec squared. So remember, to make things easy, you just say sec squared u, then multiply by derivative of u. Then here you just have to replace now. So you just have to replace here. So sec squared. So sec squared is going to be u. Our u is what? U is sine 4x. Then multiply. What's our derivative? That's that 4 cos. Okay, that right. So now you want to write it, say 4 cos x 4, then sec squared. So that's how you would do that, right? So that's something important to do. Yeah, so that's how you'd want to deal with those questions. So I think before we can trying to see what other questions we can do, so at least we can look at a number of. Okay, I think this one is more, yeah, the one who do is a little bit more complex, and I think it would be a good one to end with before we start uh, so we have that. So then we've got our sine x cubed. So how do you go about this? So again, the concept is always the same. So the concept is always the same. So you first have to define what your u is. The beauty with using the u is that you don't have is that you won't have challenges with working with very complex things. Okay, so that's what's important. So now you've got that. Okay, so what's your u prime? So that's about it, right? So that's how you find that. Then now you now go now to the code. How are you going to do the code? So remember what the code is having here. mm, how can we describe it? So what the code is having is uh, there is that power 4, isn't it? So you have to know that that power 4, even though it's been written on the code, it's actually involving everything else. Let me let me give you this picture. If you have this, it's the same as, get my point, right? So meaning this 4, it's actually for everything, right? So that's very important because sometimes it can be so easy just to forget that, right? So we know how we deal with the power. How do we do with the power? Remember the power rule? The power rule says that, isn't it? So so dy dx, so you get the 4. Then what you're going to do is it's going to be cot So it's going to be what? Cot u. Remember, why is using cot u easier? Is that for things which are looking very complex like this, it's really going to help. Like in terms of answering this, right? Like the fact that you use, at least it reduces the issue. So it reduces the stress of you having to deal with very complex things and things like that, right? So now what you know is that you are then going to have a 3 here, or if you want you could even write the 3 just where I've put a dot, right? You could even write it there. The key thing is just trying to show that what I'm differentiating had the what, uh that's the power 3, isn't it? So that's the power 3 that we're talking about. So that's about it, right? Then now remember, this is not all. When you're differentiating cot, you also have to put what? Cosec squared. So cosec squared u, and then all of this you are multiplying by u prime. So you see, when you write it like this, it becomes very easy just to plug in things without really missing anything. Okay, because you just be substituting things. And like when you want to use the sign x, everything, it's so easy to lose track, huh? So, and you wouldn't want to do that. So that's the key thing there. So any questions up to this point? Okay, is there any question? So let me say, so then you say the u then multiply everything by the derivative of u. Okay, then you have, so now what you're having is you have this and that with a negative. So everything here is multiplication, huh? Let me do this. So it's like this. So the key thing that I want to show is that this is multiplication, okay? So that's negative, right? So because you've got this, so you've got the negative, and you've got the 4. So that negative, that 3x squared and 4, that makes it what? Negative 12x squared. So then you just basically try to rearrange your answer. Okay, so you say, so everything here is multiplication, huh? So then what you do is you then want to put that, and then you have to also do that, right? So that's pretty much about it. So yeah, it looks long and everything, but if you apply the principle first using the u and then you substitute, it's going to be very very much easy on you. Okay, so that's basically that. I don't know if someone has got a question. So um then since we are concluding on this, before you can start the exponential derivatives, there are certain times when a question will ask you to prove the differentials. Okay, so let's say you've been told to say prove that is e- is what is equal to the derivative. So what you're having is sec what? Sec x tan x. So you have to prove this to prove that y, when we differentiate sec x, it becomes sec x tan x. So this is just going to be to give you an idea of really how you'd go about this thing. But I just thought it would be important just for you to know, and then you'll be able to apply these concepts for the other things, right? So, but it's very, very important that you understand this is basically the same principle. So, what you first want to remember is that sec x is what? Sec x is this is remember it's 1 over cos x. Okay? So now what you want to do is now what you what you know about this particular thing is what? You know that uh you can rewrite this using indices, right? To say if you move the cos up, remove it from the down from the bottom, the power that it had at the bottom, since there it had 1, right? When it moves up, it becomes what? Becomes -1, huh? Then you now want to differentiate that. So now let's now differentiate that. So use the power rule. So the power rule entails that what? Entails that you do the -1 comes like that. Then you're going to have cos x, then -2, right? Since you are subtracting that. And then remember from what we've been talking about, you then differentiate what's in the brackets. That's going to be sine what? Sine, oh, that's going to be minus sine x. So now what are you going to do now about this? So then you're going to say, I'm sure you can see those negatives. There's this negative and this negative. So this is making everything what? Positive, right? So let's first start with that. So everything is what? So everything is positive, and then we have something like that, right? And -2. Now remember, since that's -2, we can actually now make the cos, write it in the way that it was by saying sine x over, remember we can write 1 over what? Cos. So the cos, when the cos now goes down, okay, when the cos goes down, that power becomes a what? Becomes a positive power, right? So then let's just create space. So then we now have sin x Then we have, so what we're having is cos x and cos x. So what then you're going to do now, you want now to break down this now into what, into two. So what you're going to do is you're going to say 1, remember here there is times 1, right? So you're going to say, of course, anything that's alone, you can always think of it being multiplied by 1, right? But I'm just adding it so that you can get the picture. So then you're going to say sine over 1 cos. Okay, then multiply the 1 again, the 1 over the what, over the cos x. Because this is the same thing, because if you multiply, remember this dot that I've put there, it's for multiplication. Because if you multiply this, you're getting back to the same, right? You're basically getting back to the same. So then what you're going to do at this point then is you're then going to use now identities. Now you know, um this is what, this is going to be, so this is going to be what, this is going to be tan x, it's going to be tan x, and then 1 over cos, that's sec x. Of course we started with sec, so it looks neater to start, but again we know that multiplication is what, multiplication is commutative. So you want, yeah, you start with sec x and tan x. So that's how you would basically do for these kinds when you're taught to prove things like that. That's the approach, that's the route which you'd want to take. So yeah, so that's basically about the trigonometric differentiations. Of course, for these parts to be able to prove these things and everything, you can always be able to check through, try to solve, and it will be easier because at a time where maybe you forget maybe what it differentiates to, you can just figure, you can just easily write it down yourself, and that way it helps your understanding better, because everything you're doing is coming from what, from a place of understanding. So that's something that's important, and I would encourage you to do so. Are there any questions?